Hello everyone, welcome back to This Is Not a Science channel, and this is our chemistry video, and it's based on the previous video about a periodic table, and then we slightly covered a bit about bonding but not in detail. So I bet most people will feel a bit confused on what bonding is actually for, and I didn't really explain it clearly. So this episode we are going to talk in detail about different types of bonding. So let's start. First of all, for us to learn bonding, we actually have to figure out what bonding actually means. So why do we bond? Why do atoms bond to form molecules? Well, the term bond basically means the joining of two different atoms or similar atoms chemically bonded in order to form a different molecule. So for us to understand bonding, we have to first understand noble gas. So what are noble gas? Well, if you watch my previous video, you'll notice those are the ones at group 8, so the right hand side, that column, group 8, they are the noble gas. So what is this thing with noble gas that has to do with bonding? Well, one thing with noble gas is they have a full outer shell. So again, previous video I mentioned how an atom always wants to have a full outer shell. And the reason why atoms want to have full outer shell is because once they have full outer shell, they will become less reactive. Just like noble gas. Noble gas rarely reacts with other atoms simply because they have a full outer shell. So in order for atoms to become full in their outer shell, we can either share the electrons or transfer the electron. There are different ways to actually achieve full outer shell, and we will look at them in detail. Let's start with ionic bonding. Ionic bonding is the classic type of bonding that every people must know. So ionic bonding, what does that actually mean? We covered a bit in our previous video. So ionic bonding basically is a metal, so a metal here, the transition metal, or basically group 1 or group 2 metals, reacting with an element from the non-metal section. So as I said, metal with a non-metal, and it includes the transfer of electrons. So in this case, for ionic bonding, we are transferring electrons in order to achieve full outer shell, and the bond is extremely strong. So an example of that is NaCl, sodium chloride, or we got potassium iodide, magnesium oxide, or calcium bromide. Let's just pick a simple example to start with. So we got NaCl. NaCl stands for sodium chloride, and basically it means one sodium and one chlorine bonded together, ionically bonded together. So before we start bonding, let's take a look at their individual atom. So this here is a sodium atom. And remember, from the symbol, you should be able to tell Na is the symbol, sodium is the name, 23, the bigger number, is the mass number, relative atomic mass, and 11 on top is the atomic number, which is the number of protons, which represents the number of electrons. So we see the atomic number is 11, so we can tell from here, if you count, sodium has 11 electrons, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, with 2 in the most inner shell and 8 in the second shell and only 1 in the outer shell. On the other hand, we have chlorine. So here we have the atomic number at 17. In this case, we have 17 electrons, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So instead of having only 1 electron in its outer shell, chlorine has 7 in its outer shell. So how do we bond these two atoms together? In order to achieve full outer shell, there is a way to do it. So let's take a look at this. This is, as you might know from previous slide, this is a sodium atom. And we have a chlorine atom. Well, what's a full outer shell? Well, based on the rules, you know that a full outer shell, except for the very first shell, should contain 8 electrons. So let's count for the chlorine. We got 1, 2, 3, 4, 5, 6, 7. We need one more right here for chlorine to be a full outer shell. Whereas sodium, we only have 1. So what they're going to do now is sodium is actually going to give away his electron to chlorine. What happens is once this electron has attached on chlorine, sodium will basically lose this entire shell and alternatively become a full outer shell as well. And once chlorine has received this 1 electron from sodium, it will become a full outer shell of 8 electrons. So in the end, the product will look something like this. So we got an Na plus here, which we call it sodium, and we got a Cl minus here, which we call it a chloride. Okay, so I'm going to explain this now because this is quite a lot of information. So basically, from the previous slide, we can tell that basically sodium has given away one of its electrons to chlorine. So what happens now is, once it has given away an electron, from the previous video when we talked about atomic structure, you should know by now that electrons are negatively charged. So once you lose something that's negatively charged, you become positively charged. And oppositely, once you receive something like an electron that is negatively charged, you will become negatively charged. Just like how charges were balanced before, but now once you plus 1, because basically if you minus a minus 1, which will become a plus. In this case, if you plus a minus 1, it will become a minus. So the different thing with ionic bonding is ionic bonding contains charges. So in this case, we will call it Na plus. A bracket here to indicate that it's no longer sodium, it's a sodium ion, and it's a +1 charge. Whereas chloride, the name completely changes a different ending just to indicate that it's an ion. So we call it a chloride because it has received an electron and has therefore become negatively charged. But we all know in nature, similar things repel, but opposite things attract. So when we have a positive and a negatively charged ion, what happens is they will attract each other, resulting in such bond. We have sodium and chloride literally just touching each other because they are attracted, one of them being positive and one of them being negative. And what happens is, it's not just like this. All of them bond together, which results in something that looks like this. When you see the blue ones are the sodium ion and the red ones are the chloride ions, just because they are oppositely charged, they attract to form this uniformed crystal structure, which we call it an ionic lattice. So this will be the general shape, the general structure for ionic bonded molecules. Now we move on to covalent bond. Covalent bonding is different. Covalent bonding, as from the previous video, we will know that it's only for nonmetals, so only gas with gas. So it's only for nonmetals, and they share electrons instead of transfer. That's very important because they do not transfer anymore, and the bond is very weak compared to ionic. So examples are carbon dioxide, CO2, nitrogen trioxide, NO3, or Cl2, just chlorine. Now let's take an example of Cl2. Cl2, from its name, 2Cl, so basically 2 chlorines bonded together. So again, we have 2 chlorines right here. Just like from the previous image, these are the same identical chlorine atoms, so which means they all have 7 electrons in the outer shell and 17 electrons in total. So what happens if we want to achieve full outer shell in this case with 2 chlorines? Well, we got this chlorine right here and this chlorine right here. These 2 chlorines are actually identical. I just used dots and cross just for you to distinguish. They're actually 2 distinct atoms, so they're not similar, but they are in the same type of atom. So we got here 1 chlorine and another chlorine. So how do they achieve full outer shell in this case? Well, basically they will have to share their electrons. In this case, let's take these 2 electrons to share. Finally, the end product would look something like this. So it looks a bit odd from the previous one because these 2 atoms actually join together. They physically join together to form a molecule which we call Cl2, and it's just the name chlorine. So you can see right here in the center, we have these 2 electrons being shared between the outer shells. So if you now count 1, 2, 3, 4, 5, 6, 7, and 8, this chlorine has full outer shell. Whereas we count this one, 1, 2, 3, 4, 5, 6, 7, and 8. So this chlorine also has a full outer shell. What does that mean? That means full outer shell is achieved, bonding has finished. So this is actually a different way for two gaseous molecules to actually have full outer shell, simply by sharing a pair. Note that you have to say they are sharing a pair because this pair is being shared, not just one electron. There will never be only one electron being shared. There's always a pair. After all, we will call chlorine a diatomic molecule. Di means two, and atomic just means atom. So diatomic, two atoms. So later on, you would see some other diatomic molecules, for example, like iodine 2, I2, or Br2 or F2. These molecules, they naturally bond with themselves. So they would appear like this. If you were to zoom in a chlorine gas. Chlorine gas will basically look like this. So we have two Cls bonded together. They just naturally occur like this. So it's kind of hard for you to find a single chlorine because chlorine is actually really reactive. Just think about it. It has 7 electrons. It just requires one more electron to become full outer shell. So it will try to grab electron from any other atoms. Therefore, it's really reactive. So naturally, when we occur chlorine, it's going to look like this, where you have two chlorines attached together, bonded by covalent bond, and they share pair electrons. Alright, that's it for today's episode, and next time we will look a bit more at different examples, harder examples, because there are so many different types of ionic and covalent bond, and it's really worth looking through every single one of them because it's very different from each other, and they have a rule that we can apply on writing chemical formulas for these compounds. So make sure you subscribe my channel, you like the video, and you share it to all your friends who hate science, and we can discuss these next week. Thank you very much. See you next time.